Trigonometric equations, solutions in the primary interval. Solving a trigonometric equation such as sine of theta equals a half means finding the angles that make the equation true. An equation such as this has many solutions, for example 30 degrees, 150 degrees, 390 degrees, 510 degrees and so on. This is because the sine graph and the cos graph goes on forever, infinitely. So there's an infinite number of possibilities. We may be asked to find one solution, the solutions in a given interval, or indeed all possible solutions. If we only require one solution, we can use the inverse trig function on a calculator, i.e. sine of theta equals a half, so theta equals the inverse function of sine of a half, which is 30 degrees. So if you put into the calculator sine to the power minus 1 times a half, you're going to get 30 degrees. However, to find more than one solution, a more structured approach is required. We start by finding the solutions in the primary interval, which is between 0 and 360 degrees, i.e. the interval from 0 to 360 degrees, inclusive of 0 but exclusive of 360. Even for this interval, certain special cases are dealt with differently from the general type of equation. We will consider these first before looking at the general method. So it's important to note that in our unit circle, we start in the east at 0 degrees, we move anti-clockwise 30 degrees, 45, 60, 90 degrees, 120, 135, 150, 180 degrees, 210, 225, 240, 270 degrees, 300, 315, 330 degrees, up as far as 0 degrees again, which is also 360, and we continue around and around and around, going anti-clockwise infinitely. So special cases. The special cases are cos of the angle is equal to 0 plus or minus 1, sine of the angle is equal to 0 plus or minus 1. The angles that satisfy these equations do not lie in any of the quadrants. So for example 0 and plus or minus 1 would be the easterly point, the northern point, the westerly point, the southern point. So they don't actually lie inside a quadrant. So for example, any of these angles here lie inside the first quadrant, between 0 and 90 degrees. Any of these angles here lie inside the second quadrant, between 90 and 180 degrees, and so on. But cos of the angle equal to 0 or plus of minus 1, and sine of the angle equal to 0 plus of minus 1, they do not lie inside one of the four quadrants. Instead, they separate the quadrants, i.e. they are multiples of 90 degrees. The best way of finding all the solutions of such equations in the primary interval is to use the formulae and tables on page 13. Solve the equation cos of theta equals 0 degrees for theta greater or equal to 0 degrees but less than 360 degrees. So from the formula and tables, the solutions of this equation are theta equals 90 degrees and 270 degrees. This is if we're stopping at 360 degrees. So what we do is we go to cos of A in the formula tables and we work across. And we're interested when cos of theta is equal to 0. So when cos of A is equal to 0, we get to 90 degrees. And again, when cos of A is equal to 0, we get to 270 degrees. So that's where the 90 and 270 comes from. So we don't need to go any further because the question specifically said greater or equal to 0 degrees but less than 360 degrees. Number 2, the general method. The more general cases are cos of the angle equals A, when A is between minus 1 and 1, and A is not equal to 0, or sine of the angle equals A, when A is greater than minus 1 less than 1, and A is not equal to 0. Each such equation has two solutions between 0 degrees and 360 degrees. These solutions will be in the quadrants, i.e. they will not be multiples of 90. So they will be in the quadrants, not multiples of 90. To solve the equation cos of theta equals minus a half for theta greater or equal to 0 degrees less than or equal to 360 degrees, this is the method that we use. So cos of r is equal to a half. We're going to replace the angle with r, which is the reference angle. We would have covered this at the start of trigonometry. So cos to the power minus 1, so the inverse function of cos of a half is 60 degrees. So the calculator will give us this. So our reference angle is 60 degrees. It's important to note that we take the modulus on the right hand side. So instead of minus a half, we get cos of a half, positive a half, and this gives us 60 degrees. So we find the acute angle OR, either exactly or by calculator, so that's what we did. So OR, the reference angle, is 60 degrees. Then we determine which two quadrants have solutions, i.e. the quadrants where cos is negative. And we're interested where cos is negative because our original question gave us cos of theta equals minus a half. So we're interested where cos is negative. So we have a look at our unit circle and we know that we follow CAST. So A is in the first quadrant representing all, so all angles are positive, sine, cos and tan. In the second quadrant we have an S, so only sine is positive. In the third quadrant we have tan, so only tan is positive. And in the fourth quadrant we have C, so cos, only cos is positive. So cos is negative in the second and third quadrant. So second and third quadrant is where cos is negative. Next we're going to work out the solutions in the quadrants. So if you remember back to the start of the trigonometry chapter, when we are dealing with the second quadrant, it's going to be 180 degrees minus the reference angle. And when we're dealing with the third quadrant, it's 180 degrees plus the reference angle. So the second quadrant, it's going to be 180 degrees minus 60 degrees, which is our reference angle, which is 120 degrees. And in the third quadrant, it's going to be 180 degrees plus 60 degrees, which is 240 degrees. So solving the equation for theta greater or equal to 0 degrees less than or equal to 360 degrees, we get 120 degrees and 240 degrees. So this is when cos of theta is equal to minus a half. Recall that OR is the acute angle to the nearest horizontal. So for example, if we have a look at the second quadrant, so we know that 0 degree, this is 0 degrees, 90 degrees, 180 degrees. So OR is the angle made with this line and the horizontal. So this is the angle here. So if I just zoom in, this is the angle here. So this is the reference angle. Having a look at the first quadrant, or the reference angle is made with this horizontal, so going from 0 degrees up as far as this line. So this is the reference angle here. Having a look at the third quadrant, this is the angle or the reference angle. So again, it's between the horizontal and this line here. So this angle here is or. And having a look at the fourth quadrant, this is the reference angle here. So it's between the horizontal line and this line here. So this is the angle or. So for the first quadrant, the angle theta is equal to the reference angle. In the second quadrant, in order to find the reference angle, it's going to be 180 degrees, take away the reference angle in order to get theta. So we know from 0 all the way around to here is 180 degrees. So 180 degrees, take away the reference angle, leaves us with theta. In the third quadrant, it's going to be 180 degrees plus the reference angle. So again, this is 180 degrees, so from 0 all the way around to 180 degrees, and then we add on the reference angle to get theta. And then in the fourth quadrant, it's going to be 360 degrees, take away the reference angle. So again, this is the reference angle, so starting at 0, 90, 180, 270, up as far as our angle that we're looking for. So the quickest way to do it is to take 360 and minus the reference angle, and that will leave us with theta. So you should really learn off each of these equations. Solve the following equations. Sine of A is equal to minus root 3 over 2 for A greater or equal to 0, less than or equal to 2 pi. So it's important to note that we have a negative, and it's important to note that since we have 2 pi, we're going to use rad mode in our calculator. So where is sine negative? Well, sine is negative in the third and fourth quadrants. CAST. So tan is the only positive in the third quadrant, cos is the only positive in the fourth quadrant, therefore sine must be negative in the third and fourth quadrant. So we have sine of A equals minus root 3 over 2. So we're going to let sine of or, the reference angle, be equal to positive root 3 over 2. We take the modulus, it must be positive. So the inverse function of sine times root 3 over 2 will give us a third pi, or pi over 3. So or, the reference angle, is going to be pi over 3. So we're interested in the third and fourth quadrant because that is where sine is negative. So in the third quadrant, we need to add 180 to the reference angle, or we're actually going to use pi because 180 degrees is equal to pi, and that's because we were told in the question that we're using radians. So it's going to be pi plus the reference angle. So it's going to be pi plus pi over 3, which is 4 pi over 3. In the fourth quadrant, we need to do 2 pi take away the reference angle. So usually we would say 360 degrees take away the reference angle, but 2 pi is the same thing as 360 degrees, so it's 2 pi take away the reference angle. So it's going to be 2 pi minus pi over 3, which is 5 pi over 3. Solve the following equations. Cos of x is equal to 0.5299 for x values greater or equal to 0 but less than 360 degrees to the nearest degree. First thing we need to note is that cos is positive, so there's no minus here. So we are interested in where cos is positive, so which quadrants. So we have a look at our unit circle, and we know we have an A here in the first quadrant which represents all, so all are positive, so cos is definitely positive in the first quadrant. And we have a C in the fourth quadrant which tells us that cos is the only positive in the fourth quadrant. So cos is positive in the first and fourth quadrants. So cos of x is equal to 0.5299. So our reference angle, cos of or, is also equal to 0.5299. So into the calculator, the inverse function of cos, and we get reference angle equal to 58 degrees. So we start off in the first quadrant, and theta is equal to the reference angle, so the angle we're looking for is equal to the reference angle. So x is 58 degrees to the nearest degree. And then in the fourth quadrant, it's going to be theta equals 360 degrees minus the reference angle. So 360 degrees minus 58 degrees is 302 degrees.